I'm Narmada, Assistant Professor, Department of Cybersecurity, working in Dr. SNS College of Arts and Science. In today's lecture, we'll discuss about how big data analytics works. Big data analytics encompasses the process of collecting, processing, filtering, cleansing, and analyzing extensive data sets so that organization can use them to develop, grow, and produce better products. So let's take a closer look at these procedure. Big data analytics process. So here we have uh, different layers: a data source layer, a data pipeline is a separate layer, even data streaming is a separate layer, and data storage and processing is a separate layer, data analysis layer. So we have a different layers to process our data. Data ingestion. The process of identifying the source and getting a big data varies from company to company. So it's worth nothing that though that data collection commonly happens in real time or not near real time to ensure immediate processing. So modern technologies allows gathering both structured and unstructured data from an array of sources including websites, mobile applications, databases, flat files, customer relationship management system, IoT sensors, and so on. So it collects a different kind of data. Raw data must undergo the process of extraction, transformation, and loading. So either ETL or ELT data pipelines are built to deliver data from sources to centralized repositories for further storage and processing. With the ETL approach, the data transformation happens before it gets to a target repository like a data warehouse, whereas ELT makes it possible to transform data after it's loaded into a target system. Data storage and processing. Based on the complexity of data, it can be moved to the storage such as cloud data warehouses or data lakes from where business intelligence tools can access it when needed. There are quite a few modern cloud-based solutions that typically include storage, compute, and client infrastructure components. Storage layer allows data coming from disparate sources to be arranged in partitions for further optimization and com- compression. Compute layers are the set of processing engines used to perform any computational task and data. So there are also client layers where all data management activities happen. When data is in place, it has to be covered into the most digestible form to get actionable results on analytical queries. For that purpose, different data processing options exist. Based on the criteria of the use of one or several machines, processing environments are classified into centralized and distributed. Centralized processing, as the name implies, has all the processing happening on one computer system, so multiple users share the same resource and data at the same time. Along with the single point control comes a single point of failure. If anything goes wrong, the entire system fails, not just a part of it. Distributed processing is used to when data sets are just too vast to be processed on a single machine. Such an approach allows for breaking down large data sets into smaller pieces and storing them across multiple servers. This in turn makes it possible to process data in parallel. The great thing about the distributed approach is that the data processing takes can be moved to other available servers in case one server in the network crashes. Based on the time of processing, there are batch and real-time approaches. Batch processing, as the name suggests, the method in which piece of data accumulated during a period of time are processed in batches. Real-time processing ensures that data is always up to date due to continuous input, transformation, and output of data item. This processing time implies that all computational jobs are done within a short time span, usually in a matter of second or millisecond. Data cleansing. Before getting thoroughly analyzed, data, whether small or big, needs to be properly cleansed to ensure the best possible quality and provide accurate results. So, in a nutshell, the data cleansing process involves scrubbing for any errors, duplications, inconsistencies, redundancies, wrong formats, such as confirming the usefulness and relevance of data for analytics. Data analysis. Here, when big data turns into actionable insights, that among other things, to make sense of huge amount of data, there are several techniques and practices. We'll list some of them. Natural language processing is the technology used to make computers understand and respond to human language, whether it is text or spoken words. Text mining is an advanced analytical approach used to make sense of big data that comes in textual forms such as emails, tweets, research, and blog posts. Sensor data analysis is the examination of the data that is continuously generated by different sensors installed on physical objects. When done timely and properly, it can help not only give full picture of the equipment conditions but also detect faculty behavior and predict failures. Outlier analysis or anomaly detection is the technique used to identify data points and several deviate from the rest of the data. It widely applied in fraud detection conditions. Thank you. So from that, you can understand about big data, how we are working with a big data. Thank you.